We're going to finish up with part 5 of chapter 8. When you go into section 13, you see something fairly common with Klein, and that is just some strategy. I'm not going to talk through all of that. That's helpful for you as you are starting to solve problems. And so I want to move over to section 14. We are going to cover synthesis in a lot more detail in chapter 11, and we will have a synthesis lab that goes with it, and we will have lots and lots of practice. But in the end of chapter 8 is where you get your first taste of multi-step synthesis. All of these reactions we've learned in chapter 7, and most of the ones we've learned in chapter 8 are one-step syntheses, right? You have a starting material, you have reagents that will react with it, you make a product. As an organic chemist, our job is often to make a product that takes multiple reactions. And so multi-step synthesis is a really important part of organic chemistry. It's also one of the more challenging parts. We learn all of these reactions, and this is another reason why it's really important that you learn them. And then I give you a problem, and you have to pull from all of these new organic tools that you're learning to solve the problem. So we're going to start small, thinking about the 3 big types of reactions we've learned: addition, substitution, elimination, right? If we look especially at addition and elimination right now, we are going to see that we go from double bond to a single bond with new X and Y groups. Whereas elimination, we take the X group off and we make the double bond. We're going to utilize these together. So some simple one-step synthesis. This is the practice you're going to do from chapter 8 on your homework and all of the extra practice I've put up for you online. But what I want you to bring your attention to is the idea of moving functional groups. All right, so first of all, we are going to start by moving functional groups. In particular, we're starting with moving halogens and alcohols. We're then going to take a look at moving double bonds in another slide. If we just need to move a halogen or an alcohol over one position, it's often a very, you're going to start seeing this as a very repetitive combination where you're using elimination as well as addition. All right, you're taking the functional group off and then you're putting it back on where you want it to go. So let's take a look at the example they gave here. Right? We want to go from having the bromine on this second carbon from the left, right? And we want to move it over to the third carbon from the left. So we've got to take it off first. Now, to do that, we need an elimination. You guys have learned all about eliminations in chapter 7, but specifically, if we're trying to move the bromine to the right, we need to eliminate to the right. So it's important that I recognize that this is a Ch8 product. How am I going to eliminate to get a Ch8 product? I'm going to use a strong, non-bulky base. To make sure I get elimination, I'm going to go ahead and use a protic solvent. That is going to give me my Ch8 alkene. Now from here, if what I want to do is add bromine, and I want the bromine to go to the more substituted side, right? I recognize that as Markovnikov. All right, now what is going to give me a Markovnikov addition of HBr? Well, just simply HBr, right? Just make sure you don't put peroxides in it. So you see that you're going to use elimination and addition over and over again, but it's why we harp on regiochemistry concerns, right? You need to know the difference between Ch8 and Hofmann, Markovnikov, and anti-Markovnikov. If we wanted to take this same starting material, and let's say now we wanted to move the bromine in the other direction. Well, it's still going to be an elimination and an addition. We're just going to have to choose different reagents. All right, so how are we going to do this? Well, let's go down and around. Now I need that double bond to go to the Hoffman position, right? The less substituted position. For that, I'm going to use my bulky base. You know me, I like to use potassium tert butoxide. That's what TBUOK is. Tert, butoxide, and then the potassium. It's just easier to type it that way. Now, if I want to add bromine to the less substituted side, right, I'm going from this Hoffman product to this anti-mark product. I would use HBr, but now I need those peroxides. Right? So you have multiple choices. There are multiple ways that you can move these functional groups around, but the underlying strategy, right, is eliminate it, bring in that double bond, and then do your addition reaction. This is really useful because it allows you to bring in all sorts of different functional groups. All right, so this is just what we just did. Instead of sodium hydroxide, Klein used sodium methoxide. That's totally fine. When this brings up a very good point. When you are doing synthesis, I cannot stress this enough, and I hope you are listening. There are often multiple ways to do synthesis. If you think that your way works, but you see a possible solution from me that's different, don't just assume you were wrong. Maybe you were wrong, but maybe you were right and you did something different. If you ever want me to check to see if your way is possible, please email me or come to office hours. This is my favorite part of organic, and I'm excited to help you through it. This is challenging, but it's also something that's really rewarding. If you like puzzles at all, this is sort of like the mother of puzzles. And so I want you to give yourself time to get good at this. Please take this opportunity in Chapter 8 because it does get more complicated. And if you can start building some synthesis muscles here, it really and truly will help you. Now we can move alcohols around as well. It's the same idea though. We're taking an alcohol from one carbon and we're moving it to an adjacent carbon. So it's still an elimination and an addition. We just have to be thoughtful about how we can modify an alcohol versus, oh sorry, that is not a hydrogen, versus like a bromine. So we got a methyl there and an OH here, and we're ultimately trying to move this OH down. So I'm going to go down and around again. Now we see that we want this to give a Hoffman product. We cannot just treat this with a bulky base because it's an alcohol, and alcohols are not good leaving groups. Now you could use H2SO4, but that's going to give you the Zaitsev product. This is going to take us an extra step. If you want to get a Hoffman product from an alcohol, let's go ahead and use tosyl chloride first. Now we have a lot more control. We can take that OTS group and we can eliminate it in any direction we want. It's going to act just like an alkyl halide, and so now we can bring in that bulky base, all right, that tert butoxide. Once I have my alkene in place, this becomes a lot easier, right? Now I'm thinking about what's an anti-Markovnikov way to add an alcohol. Well, that's where my hydroboration oxidation comes in. You can start to see why it's really important that you know these reagents. Because if you don't, these synthesis problems can be, well, they can be impossible. But if you know the reagents, it's much easier. So definitely start working on memorizing those reagents. And here you go. You see this, this same method that we just did. Right? I always just put BH3. THF can be in there. Diglyme sometimes is useful. I really just focused on the boron reagent. All right. Now, the last thing I want you to practice with is multi-step synthesis, moving a double bond. It's the same idea as moving the other functional groups. It's just, it's an addition and then elimination instead of the other way around. So if we've got this double bond and we want to move it out to the left, then we are going to put something on in a position so we can eliminate in that direction. All right, so we'll start off with adding bromine. Now, we want the bromine to go to the less substituted position, so we're going to use our peroxides to make sure that happens. We want the double bond to go to the less substituted side. We want the Hoffman product, so we're going to use potassium tert-butoxide to make sure that happens. All right, that's why this, again, this regiochemistry has been so important. All right, we want anti-mark up here, anti-mark, and Hoffman down here. All right, and so we're just reiterating what we just said. This requires practice. There is a little bit, I think there's maybe like 1 or 2 questions in your homework. I will make sure you have some additional practice. Please work on